Nothing like a good pair of binoculars to look at these star clusters in Cassiopeia and Taurus. Hello, everybody. Glad that you're with us at the American Space Museum as we keep you today star curious on Stay Curious with some backyard astronomy tips from me, Stargazer MarQ. So glad that you've joined us on Facebook Live, Twitch, YouTube, and Spotify video programs 5 days a week on our video podcasts. And we're also doing audio on Google and another one of the channels out there, Google and Apple, actually. So we want to welcome everybody, and you can see our stargazing programs in the backyard astronomy up on our library on Facebook and YouTube. Marty Winkle is my cameraman co-producer. Would you mind trying to prop that up, Marty?
Yeah, just do it.
Okay, thank you.
I'll get it. The left is in the
Okay,
way.
we're so welcome to have in our crowd today, George and Bonnie Smitty. George is over here. Bonnie's out there enjoying our beautiful museum. Thank you, Marty. If he'll stay, that's okay. If not, all right, good. My whiteboard there, I was looking at for a few notes there. But today we've got an interesting program. I'm out in the backyard, all right, dressed for stargazing. And you up north, of course, you got to get dressed. And if you don't, you're not going to have as a pleasurable experience. So be smart about what it is like outside. And got my star map here, and it's set on the February 1st. It could be the first time of the month here, but we're at the first week of February. The moon is new on February 1st, so a great time to go out and see 8 bright stars that form a hexagon or a G in the sky. And we're going to talk about those 8 stars in just a minute. But I wanted to make sure you know how to use a planisphere. This is your star chart to the sky, your road map. And you put it over your head. And if it says north, you want north to be pointing north and your head under it. Or south, I get under it like this, looking south, like towards Miami. And the red light, that's so you can read your star charts at night. Because if you use a white light, that as your eyes dilate and you see more stars and things in the dark, a white light's going to wipe that out and contract those pupils. It's exactly like when you go to bed tonight, you flip off the light and jump in bed. You can't hardly see anything in the room. And right before you doze off, 5 minutes later, you see everything in the room in detail because your eyes have opened up. Well, that's the same thing in your backyard. So when you're doing your backyard astronomy and finding these 8 stars, like I know you want to, if the neighbor never turns off that light, block yourself in your backyard with a tree or pole or something. You might not be able to see all the sky, but then maybe you can move to another spot in your backyard to look at the northern sky if you can see the south. So kind of be smart with that and don't get direct white light in your eyes, and you'll have a more pleasurable experience and see fainter stars. We've already done a program on binoculars. Here's a little $10 adapter you can buy on Amazon Smile to support your favorite nonprofit, the American Space Museum. Every pair of binoculars has a screw outlet in the middle that a screw on this fits in, and you screw this on, and then this fits on a tripod. And bingo, you're moving a tripod around steadily, enjoying stargazing. It's hard to do wobbling around like this. And if you or prop it on something or prop your hands down against your chest, that creates a more solid when you're wobbling around looking at things. So you don't need to have a lot of expense to get into stargazing, and that's why we want you to stay star curious on Stay Curious, because you're going to learn a little bit about these bright stars. I am getting a little hot out. The temperature went up, Marty. Once again, we've got Marty Winkle, my friend and co-producer. We're approaching 500 episodes together, Marty. Imagine that. And whew, I'm getting a little hot here. I got my Floydster hoodie on here, and I'm going to take this hat off because we just have a temperature inversion in here. But we know it's cold and a lot of snowy areas, particularly in the New England area. And we have George and Bonnie in the studio. George is Marty's nephew. And you guys are in New Jersey. Did y'all get a lot of, your friends say about a lot of snow?
Yeah.
How much did you get up there? Long Island area and stuff. New York.
4 or 5 inches at the in the northern
Yeah.
part of the state.
Yeah, Marty's going to pan over there, make his nephew famous there. There's George and Bonnie. They're going to enjoy a rocket launch tonight. Okay. And we're back here socially distanced there. We do require masks in the museum. And there we are back outside. My best friend, one of my best friends up there, George Fleener, shot this from White Top Mountain in Virginia, just off Route 81. You traveling people up there. So beautiful shot of a twilight setting there. Marty came up with an awesome little tidbit as we roll into February, the month of February 2020. My mug here says, caution, may start talking about astronomy. Marty got me that for Christmas. He gives the best Christmas gifts, doesn't he? I know he probably got you something that
No.
no?
No.
Oh, well, no. Oh, okay. Well, you will now. Which one did you give the whistle and pickle to? It wasn't him?
No, my son-in-law.
Oh, okay.
Between my kids and my grandkids and great-grandkids, my budget.
His budget's there. Well, he got me this, so don't be jealous. But yes, I may randomly start talking about astronomy. Excuse me. But Marty started randomly talking about astronomy the other night. I'm going, what? He says, I know something about February that it only happens once every 423 years.
No, 823.
823. Yeah, 823. 823. Okay. So 823. What would that be? And I saw something about leap year, leap day, because we'll have a leap year next 2024. No. And it is this. Every 823 years, February, each day of the week has 4 weeks. So 7 days of the week. No, they don't have 4 weeks. They're on 4 dates. Each day of the week has four. There's 4 Mondays, 4 Tuesdays, 4 Sundays, 4. What's after Sunday? Monday. I already said that. 4 Wednesdays, Thursday, Friday. Every day of the week has 4 dates. 4 times 7 is 28. And Marty says that the next time that will happen is in 2845. 2845. That's the Zager and Evans song from the 60s. In the year 2845, we'll have every day of the week, we'll have 4 dates in it. So that might win you a pizza at the trivia contest here coming up this weekend somewhere. So, but Marty, thank you for that tidbit of February, the shortest month, and good riddance to January. A lot of people are saying, I'm sure. So, well, we're going to show you these 8 stars. Someone said to me once, you've seen one star, you've seen them all. Well, nothing could be farther from the truth, I said to that ex-wife. And the fact is, every star you see in the sky is just as unique as every person is on Earth. Every star is different in size and age. More than 2/3 of them have another companion star orbiting them. We're going to talk about one star in a minute that's got 5 stars orbiting around it. And now we know that hundreds of our closest stars have thousands of planets orbiting around them that we call exoplanets. So indeed, much like snowflakes, no 2 stars are exactly alike. And in this week's winter's night sky, there are 8 of the top 20 stars you can see. 8 of the top 20, that's 40%. And they're all at least first magnitude, a scale of brightness where the lower the number, the brighter the object. So if there's a -1, which we have Cirrus, the brightest star, that's bright. The most faintest star you can see from a really dark site like White Top Mountain up here after sunset is about what we call 6th magnitude. This is a logarithmic scale where 6th magnitude is 2.5 times fainter than 5th magnitude, which is 2.5 times fainter than 4th magnitude, and so on. But it's when you start multiplying that from the 1st magnitude star, like I said, there's 7 of them and a negative number up right now in the night sky, to the 6th magnitude is a scale of about 2,000%. So visualizing the exact properties of these stars is a challenge even met by modern astronomy, and that's what the Webb telescope is all about. A couple of these stars I described, we're going to see the surfaces of, thanks to the Webb telescope, not in a visual optical way because it's a telescope that works in the infrared detecting heat signatures, but we're going to be able to understand if there's star spots and flames coming off of other nearby stars. And indeed, are they all round, which I say Betelgeuse and Aldebaran we're going to talk about are probably like those gigantic balloons you see kids play with, the bubble things and rolling around and not a complete sphere. That's my projection here. But so we're going to have fun looking at visualizing the sizes of stars and seeing these diversity of stars in the sky. And so, yes, indeed, we have what we call in the sky here. On the left is the hexagon of the sky, or the G, letter G in the sky. And there you see the stars at the top, Capella, 42 light years away. And you see as we go around, there's some that seem to be kind of close. Procyon and Cirrus there are the two closest, and Sirius is indeed brightest because it is closest, all right? What is a light year? It's the distance light travels in one full calendar year. Again, an arbitrary scale, but at 186,000 miles a second, or 7 times around the Earth's 25,000 mile diameter crater in 7 times in 1 second, that's how fast it goes, it's about 6 trillion miles. 1 light year is about 6 trillion miles, okay? And from here to the moon is like a half a light second. So bouncing something off the moon and back takes about a second. And many of you have seen that done on the sitcom Big Bang Theory. That's one of my favorite episodes, where they go up on top of their rooftop in Pasadena and bounce a laser off one of the lasers platforms that was left by one of the Apollo missions there. Takes about a second, half second there and half second back. So everything's a time machine looking back in space. And so we're looking at Cirrus there at the bottom, light that left it in 2014, okay, 2014, and so on and so forth around there. Yes, some stars are bright because they're close, but a couple of those stars are really bright and yet they're far away, like Rigel. See Rigel there at 800 light years? If we put it where Procyon or Sirius is, all right, at about 10 light years away, Rigel's light would cast it'd not only be visible in the daylight, it would cast a shadow in the daylight, rivaling the sun. It is so powerful, all right? So that gives you a little idea of what we're going to look at today. To stay star curious, there's the G asterism in the sky. Starts with Betelgeuse, Rigel, Cirrus, Procyon, Pollux, Castor, Capella, and Aldebaran. Some weird names there. They're not not even Latin sounding names, and they're not. Interestingly enough, though, the constellations are named after Greek and Roman mythology, the star names were named by the ancients thousands of years, and most of them date from like the 2,000 to 4,000 years ago in the Mesopotamia cradle of civilization area we call Orion and Iraq. And these were Arabic names. You have a lot of L's and Al, like Aldebaran. Well, Al is really a prefix, okay, meaning the eye of the bull is what that means in Arabic, all right? Betelgeuse there. You know what that means in Arabic, Marty?
Yeah, but I forget.
Armpit of the giant. All right, Betelgeuse. They shorten their things up there. And Cirrus is just as it's named, it was named Cirrus. That's an Egyptian name. So, to emphasize that all stars are not alike and a lot like people, different sizes, not so much different shapes, because we're all generally in the same shape, just some of the size of those shapes are different, okay, particularly around the middle as you get older. And so that's why we talk about astronomers as we age, we get bigger, because you add G to astronomy, you get gastronomy, the science of food. So it's unavoidable. There at the top, we see a nice little chart showing you the planets, Earth, Mars, the Sun, and Cirrus, okay, all together there. You got the Sun, you got Mars, and the Earth, all right. And what they're showing on the far left of Mars is called Wolf 6539, and that is a star that's actually smaller than Mars. It's kind of burned out. Number 2 up there, no, it's Mercury, Mars, Venus, Earth. I'm sorry, Mercury, Mars, Venus, Earth at the top one. Yeah, the wolf is in the middle one. So you see that Venus and the Earth are about the same size. Mars, though big in our minds, is half the size of Earth. Then we go over to number 2. Are other planets the solar system compared to the Earth? Very big. Now we're comparing Jupiter on number 3 in the middle panel with a small star, our sun, and Cirrus, the brightest star in the sky. Cirrus is bigger than the sun, but it's not doesn't put out as much energy, and that's why it looks so bright. It's so close. Then we got Cirrus, the biggest star on the panel before, is now the smallest, and it's compared to Pollux and Arcturus. And then number 5, we've got Aldebaran, Rigel, Antares, and Betelgeuse compared. And then Betelgeuse, if we put Betelgeuse where our sun is, it would swallow the orbit of Mars. It is so huge. It would swallow the Earth. It would swallow Venus. It would swallow Mars. It's so big. But it is dwarfed by some other gigantic stars. So, again, stars are different sizes, all right? Not so much different shapes, but it's incredible how the close ones impact us. And we're going to talk about, there is the beautiful Betelgeuse pointing there, and the familiar 3 stars of the belt of Orion coming up over a winter landscape. You see off of the 3 stars of the belt are another 3 stars. That's his sword. But the middle star is actually the great nebula of Orion. It's not even a star. All right. But we're going to talk about Betelgeuse up there, pronounced Betelgeuse, translating in Arabic, armpit of the giant. This is a huge star, like I said. It would fill up our solar system to the orbit of Mars, and it fluctuates in brightness. We are waiting 2020. It had dimmed, and I actually went outside and noticed one night, Arcturus doesn't look bright. It doesn't look as bright as the top star to the above it is Bellatrix, and it's usually just a little dimmer than the other bright star, white, you see above the treetop. That's Rigel we're going to talk about here. But so I noticed this after stargazing for half a century, and it was dimming. And what happened was it may have thrown out some gas, for that matter, simplicity, that obscured the planet as we see, the star, as we see in these photos taken by the European Space Agency's time on the Hubble telescope. Not only did it dim in brightness, but its brightness faded in the Hubble telescope. And there we have again, Betelgeuse is a little bigger than Antares. Now we've got Rigel, Bellatrix, and Aldebaran, and they've got their magnitude there. They're all around first magnitude. Aldebaran we're going to talk about in a minute, towards the last star. That's the eye of the bull Taurus. But Rigel over there on the right, that is the kneecap of Orion. And Rigel is a blue-white star with a surface temperature about twice of that of Betelgeuse. That's why it looks hot white. Star colors give us an indication of how hot they are, just like a hot plate. Red, is a little cooler than one that's white, really white hot. Same principle there. So light we see from Rigel there left 910 years ago. So its output is tremendous. Again, it would be visible in the daylight sky on Earth if it was as close as Cirrus is. There is Cirrus, easy to find, not only the brightest star, but you take the belt of Orion in reverse, you drop into it. You see a pattern below Cirrus of a stick figure of a man. This is the dog star. It is in Canis Major, the big dog. And you see the star in the upper left-hand corner. That's Procyon, the brightest star of the little little dog. It's not labeled, but it's the biggest one up there, almost off the screen in the upper left. We'll see that in just a minute.
You want to circle it?
No, we'll see it just a second here, another frame. That is a telescope picture of Cirrus, the brightest star. You're not going to see anything disk on it, but it will look like the lines through it are caused by an artifact of the telescope. That's actually part of the structure holding the secondary mirror in a telescope. Still a beautiful picture. Blue-white, like a blue-white hot flame. Think of that. Cirrus is 10,000 degrees hot on the surface. The Earth is 6,000. if, like I said, if it traded places with Rigel, Rigel would be seen in the daytime. It's called the dog star because it was so important to ancient Egypt. They called it Al-Shira. When it was seen rising in the morning sky before the sun, which is in April, the Nile River would soon flood, bringing fertility. Then the star was known to be in the daytime sky, though it couldn't be seen. Ancients knew that Orion in the summer months is like it is this month of February, standing directly south, except the sunlight blots it out. They had that figured out at least. So they thought this star up there created more heat on the Earth because they didn't understand it was, 10 light years away. They thought it was part of a celestial sphere close to Earth, and that heat heated up the Earth. Therefore, they called it the dog star and the dog days of summer. All right, there's again a nice picture of the constellation Orion, and you see at the very bottom Cirrus, the brightest star, and then on the upper left is Procyon. Procyon is also in the sun's neighborhood, 11 light years away. That means at a speed of 186,000 miles a second, the light we're seeing from that star right there, where it says Canis Minor, left in 2011. And yes, those three stars form what we call the Winter Triangle. Not an official constellation, but what we call an asterism in the sky, where different stars from different constellations make up a pattern that's easily seen. So Betelgeuse, the armpit of Orion, Procyon in the little dog, and Cirrus in the big dog make up the Winter Triangle. And all of these stars are brightly seen from your own backyard, even if you're under light-polluted skies with a car lot beside you or something. You can definitely see all these stars. Let me get a little rocket fuel here and keep talking about astronomy. Here we have another beautiful look at what a desktop planetarium would show you. There you see Orion in the lower left, Aldebaran, and at the top are two stars, Pollux and Castor of Gemini the twins. There you see Procyon, and you see that Cirrus on the left, Procyon at the top, and Betelgeuse make the triangle. Auriga we're going to talk about. First we're going to talk about Castor and Pollux. Castor and Pollux are the two bright stars at the very top up there in the Gemini the twins, and it makes kind of a drop down. Stars are like parallel each other like twins would be. There you see dropping down the stars of Castor and Pollux. All right. As you see at the top, they're outlined there on that planetarium look. All right. They're beautiful stars. Castor at the top of the brothers is an astounding system of 6 stars orbiting each other. Crazy astrophysics there, but there are 6 stars, actually 2 pairs, an inner pair and an outer pair, and then a third pair going in and out around it. So with the naked eye, it looks blue-white at first magnitude. With the department store telescope, you can see that Castor has 2 stars that are closely revealed. So you can see 2 of those 6 orbiting stars. 45 light years away. So the light that left it 45 years ago. Now Pollux, all right, in Gemini, it's Gemini the constellation and Gemini the space program. Pollux is an orange giant that is 36 light years away. It couldn't be different from its brother. An orange giant means it's near the end of its life. It might be born at the same age, but it was too fat and used up its energy too quick and started expanding. Members of the ancient stories of the Argonauts crew, both brothers shared Leda as their mother. Greek mythology says they were born from different fathers. Roman mythology is they founded the city of Rome. So, but awesome and incredible stars. Here's a beautiful picture. You think one star is alike. You see one star, you've seen them all. No. One is Castor on the left, or Pollux on the left, and Castor on the right. In a very not easy to do photograph in astrophotography with a telephoto lens showing you the colors there. Well, one interesting constellation. We got 2 more stars to talk about on Star Curious here on Stay Curious. We're so glad that you're watching us on YouTube, Twitch, Spotify, and of course Facebook Live. and tell your friends all about us, to like us, share us, follow us, and subscribe to us, because that's how our nonprofit can reach out and do more programming for, most importantly, your children. Our STEAM education is very important here, that we ignite the future generation with new ideas from our wonderful relics from the birth of the space age. Well, here is a constellation outline called Auriga, the charioteer. Auriga is a gentleman's name from back in the past days. Now, of all the names I've heard out there, I've never heard of a wide receiver in football named Auriga, but maybe we'll find one here coming up soon. Who was Auriga? Well, that is a question for the ages. And one answer I have is, where's my Auriga note there, is that he was a charioteer from the ancient days. Why wouldn't Auriga be why would they put a charioteer and memorialize them 4,000 years ago in the sky? And this is a 3,000 to 4,000 year old name on a constellation that looks like a house with Capella at the top of the house. So I am saying that that Auriga might be the guy that invented the wheel. How about that? All right. Why not? Maybe that's why he's immortalized as the charioteer. Anyway, Capella is the bright star. It's a beautiful yellow, almost gold star. It is, how far away is it? It's 42 light years away. It's the 6th brightest star in all of the top 20, and yet it's largely ignored because it's towards the north of all these stars. It's towards Cassiopeia, the W or M in the sky, you'll see in the northeast, right now in the sky. And when you look at it, you'll go, wow, it's not that much fainter than Procyon and Cirrus, but a very beautiful star, ranked 6th in the top 20. Capella. Now, Capella is a beautiful name, and I've heard of Capella University on TV advertising their stuff. But Auriga, I've not even heard a cat named Auriga. If I get to have another cat, there'll be a toss-up between Auriga and Alberio, maybe. We'll see. Alberio is the star in Cygnus, the swan. So, well, there you have almost complete set of the G's formed in the constellation. We went around from Betelgeuse, Rigel, Sirius, Procyon, Pollux, Castor, Capella, and now we're dropping down to Aldebaran. And Aldebaran is the eye of the bull, our last stop. And of course, beautifully overhead above Orion, easy to find. It's going to start dumping to the west as the Earth is moving around our solar system here around the sun. But it distinctly has a group of V-shaped stars that are within that circle there. And the horns of it are those two at the ends of the lines. So his face is what's charging us. And we say up in the shoulder is where the Pleiades star cluster is. And when you see the Pleiades in the next few nights, because the moon's going to go from new moon February 1st to crescent phase, so we're going to start seeing the thin new moon in the sky. Ancients, North American, had legends that those Pleiades looked like a crack in the sky to them. And they thought that's where souls were escaping as they died through that crack up into the great unknowns, or heaven, or whatever the ancients called that. So pretty universal theory there that the Pleiades, they didn't know they were individual stars. They didn't even know what stars were. They thought every star in the sky was a wonder of creation to guide us. And there's 5 wandering stars, the planets. So Aldebaran is another big, fat, rosy red star, bloated like a Betelgeuse. It would swallow up the Earth, not quite go out to Mars, all right. It's 68 light years away, and it's another star, Marty, that we're waiting to blow up some night as we get outside. Well, I'm going to get back out underneath the stars again, folks, here, and go out and check out all those stars of the hexagon. And we've got some people that have, Marty's coming in from the warm inside to let me know that we appreciate Dave staying up there freezing to death in Michigan watching us. Space Resources, thank you. Drop us a line. Maybe we can exchange resources out here. Humberto, Veda Lopez. We've got Robert Law is watching up in Dundee, Scotland. He'll be checking me out now and making sure that I'm right about that G up in the sky. Thank you, Hazel, for watching. Now, Cliff Watson, my buddy Cliff, everything's going to be upside down for you there, my friend, because he is in Sonoma, Australia. All right, a regular watcher. And we have Athana Hayamba, Matama Hayamba. Tell us where you're from. I'm terrible at that names, but one name I can pronounce real well. Thank you, and I love you, my daughter, Jessie Marquette, with my granddaughter, McKinley. So I'm going to, as she knows, she's seen me many a night, my daughter, Jessie, has out there looking at the stars and loving it. So I'm going to get back out there. Let me see what I'm going to find on my map here that's risen up in the east. That's what's always fun, is something's always rising that's new as you go out hour after hour. So great. We're looking at Leo the Lion is about to rise, and that is a good sign of summer, of spring for everybody out there. So until we see you again for Backyard Astronomy, go out there in your own backyard. Take a refreshment with you, some snacks, a nice cozy chair, dress for it, and go see if you can find these 8 stars of the winter octagon or the winter letter G, like I did today, to help you all stay curious. Marty, thank you, buddy. We'll see you next week. Bundle up.